In this video, I will show you how various transformations affect the graph of a function. Before we get started, let's use these notes to remind ourselves what the basic transformations are. Now, I'm using a square root function, but the same idea works for any function. So first of all, if there is a negative sign in the very front, that's going to be a reflection over the x-axis. Now the a value controls whether or not you're going to have a vertical stretch or a vertical compression. Ignoring the negative sign, if the a value is bigger than 1, then you've got a vertical stretch. If the a value is less than 1, then it is a compression or shrink. Now, if you have a negative sign inside the function, that's a reflection over the y-axis. Now, ignoring the negative sign, the presence of a b value is going to do something horizontal. In fact, everything inside the function is horizontal, and it's going to be kind of the opposite of what you would think. So, it's going to be a horizontal stretch, actually, if the b value is less than 1. So that's the opposite of what you would think, all right? So if this was, if b was 1/2, or, let's say it was 0.5, that would actually be a horizontal stretch. Now, if the b value is greater than 1, then it would actually be a compression. And I put the word reciprocal here. If the b value was 1/2, then the stretch would be by a factor of 2, all right? Because of the reciprocal of 1/2 is 2. If the b value was greater than 1, let's say the b value was 3, then I'm telling you that's a compression. But what's the reciprocal of 3? 1/3. So the compression would be by a factor of 1/3. Anyway, if there is an h value present, that's going to shift the graph left or right. And again, it's the opposite of whatever it looks like. So if this is a negative number, it's actually going to move you to the right. And if this is a positive number, you're going to move to the left. Finally, if you have a number in the k position, this controls whether the graph will move up or down. And if this is positive, you move up. If it's negative, you move down. So that's a basic review of how these numbers, these changes to the parent function, will affect the graph. And in this case, the parent function was y equals the square root of x. And it works the same way for any function. So now let's play around with some other functions. All right, so based on what we just saw, if we have a -2 here on the very end, this is the k value I was talking about. This should shift the graph down 2. So I'm just going to move all of these 4 key points. I'm going to move them all down 2. So that's going to look like this. If I move this down 2, so the graph after this transformation is going to look something like this. Okay. Now, a +1 inside the function, this is that h value. So this is left or right, and positive is actually to the left. So you know what, maybe I should write this down actually. So a -2 right here, that this was going to be down 2. Okay, a +1 in this position would be left 1. So that's going to go like bam, 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 bam. All right. Now, I told you that a negative sign in front of the function is going to be a reflection over the x-axis. Okay, so here's the x-axis right here. So this point is 3 up, so a reflection would be 3 down. This is 2 up, so I'm going to go 2 down. Back to 3. All right, this point is right on the x-axis, so it won't move. So the reflection is going to look something like this. And notice if you look at the double image, the x-axis is the line of symmetry. So that's how you know we did it right. All right, what's next? So this is the A value, and this is going to be a vertical compression. Or you could say vertical shrink. Okay, vertical compression, vertical shrink, by a factor of 1/2. So that means all of the y values will be cut in half. So for example, this y value of 3 will become 1.5. The y value of 2 becomes 1. 3 becomes 1.5. Y value of 0, half of 0 is still 0. So this point isn't going anywhere. All right, so the new graph after a vertical compression by a factor of 1/2 is going to look like that. All right, I told you that a negative sign inside the function is going to be a reflection over the y-axis. All right, this is going to be a little bit tricky because this is going to put us actually onto the other graph. Okay, I really didn't leave enough space for this, but let's do it. So here's the y-axis. So notice that this first point is 1 unit to the right, so I'm going to have to go 1 unit to the left. This point is 2 units to the right, so I'm going to go 2 units to the left. And this point is 3 units to the right, so I'm going to have to go 3 units to the left. All right, now this is really going to mess up the graph. This point right here, of course, is 5 units to the right, so I'm going to have to go 1, 2, 3, 4, 5 units to the left. Okay, so I'm sorry to interfere with my previous graph, but this should look something like this. Okay, that was a little weird. All right, here we have another A value, and so that's going to be a vertical, and it's going to be a vertical stretch, all right, because it's bigger than 1. All right, we say a vertical stretch by a factor of 2. In other words, all of these y values should be doubled. Okay, so this is going to be off the graph a little bit because this is a y value of 3. If I double that, it should be 6. So that should be just actually a little bit off the graph here. A y value of 2, if I double it, that'll be 4. All right, and again, this should be up here at 6. All right, this point won't move. It's on 0. 2 times 0 is still 0. So this graph is going to look something like this. Wow. All right, I might cheat and use my line drawing tool for the last little bit there. All right, that's a long way to go for me to freehand that bad boy. Okay, so I'm going to just cheat and go like that. Okay, great. All right, vertical stretch by a factor of 2. And here we have this k value, this minus 3 on the end. Didn't we already do that? See, we had a minus 2, that was down 2. I feel like they're repeating now. This is just going to be down 3. So I feel like they're repeating themselves. Okay, great, down 3. So this is going to be like this. All right, if I take this and move down 3, so this should basically look like this. Okay, all right, you know what? I messed it up a little bit. My OCD just kicked in and would not let me move on. All right, that's a little better. Okay. Now, this is something new that we haven't talked about yet. A little negative sign here means that we're going to be graphing the inverse. All right, so the inverse is where you reflect something over the line y equals x. Okay, so first let me draw the original function, which I think I'll draw using this color. So the original function looked like this. We had 1, 3. All right, so here's the original. Okay, so the original function looked something like this. Okay, that's pretty close. Now, the line y equals x is this diagonal line that goes at a 45-degree angle like this. All right, that is the line y equals x. All right. So if we're going to graph the inverse, which is what this means, let me just put inverse. Then we need to reflect each one of these points diagonally over this line. Now these 2 points are on the line, so they're not going to move. So these 2 points are going to stay right where they are. I wish they would stop disappearing. Those 2 points are not going to move. This point is going to be reflected over the line. So it will be right here. I'm reflecting diagonally. This is diagonally 1 square away. And so I'm going diagonally 1 square in the other direction. Now, what about this one, this final point over here? Now, this is, if I'm counting diagonally, this would be 1, 2.5 squares away. So there's my half, and then there's 1, 2. So this point is going to land right here. There's another way I could have done this. I could use the coordinates as well. I probably should mention this. So the coordinates of this point right here are 5, 0. So if I want to do the inverse, I just reverse the x and the y. So this would have to be 0, 5, which of course is right here. So that's another way to find the inverse. Now look for that cup and handle shape, and hopefully you can see that here's the cup right in here. All right, here's the cup shape. And then here is the handle. Okay, so that red the red is the inverse that we were supposed to graph. Okay, the blue, of course, is the original function. All right. Let's just keep practicing doing the same, or just doing the same thing with another graph. Okay, so this plus 3 on the end like that means that we go up 3. Okay, so if I move all of these key points up 3, that's going to be 1, 2, 3. All right, I'm really missing the grid that we had before. I liked that better. Okay, up 3, 1, 2, 3. Okay, 1, 2, 3. 1, 2, 3. And 1, 2, 3. All right, I don't know if I can make these segments this small, but I'm going to try. See if I can get away with it. Oh, you know what? I need to lock drawing mode. Okay. So we just moved that graph up 3. And you know what? That just gave me an idea. Let me change colors before I do this idea. I should have thought of it before. We can do an even better job, sort of cheating in a way, if we trace this thing right from the beginning. All right, that'll sort of guarantee that it matches perfectly. Okay. So now that we have this perfectly traced, we can just move it wherever we need to move it. So this one is going to be to the left 2. So I should be able to just move this whole thing to the left 1, 2. All right, and that's it. We just move it to the left 2. Yeah, I'm supposed to write that down. So this is left up. I lied. This is the opposite of what it looks like. So this is actually to the right 2. That was a careless mistake. But luckily I cheated. So I can just go like this. So this was now moving to the right 2. Great. Now, this one, this is a reflection over the x-axis. Okay, this is going to be a reflection over the x-axis. All right, so this thing needs to be turned upside down. I'm not sure if that can be done in a cheating fashion, but I'm going to try. Let's see. Flip vertically. All right, that seems to have turned the whole thing upside down, which is what I wanted. Okay, so this should be like this. Okay, a reflection over the x-axis. All right, now, that might have to be the end of my cheating. think I'm going to have to go back. Oh, I wanted to, can I change all of these at once? Because these should be purple, right? Got to keep the color scheme going. Okay. Now this 1/2 in the front is going to be a vertical compression, or I think I'm going to say vertical shrink. Just because it's a shorter word. But so it's going to be a vertical shrink by a factor of 1/2. So all of the y values should be cut in half. So this y value is going to be just half of a space. This is going to become just half of a space. All right, this 2 is going to become a 1. This 1 is going to go to half of a space. What is this? 1, 2, 3. This 3 is going to become a 1.5. And a half of 0 is still 0, so that one's not going to move. All right, so this is going to be like this. All right, something like that. Now, the next one, when you have a negative sign inside, that is a reflection over the y-axis. All right, a y-axis reflection. Okay, so this point is 2 units to the left, so I'm going to have to go 2 units to the right, and there should be a dot right there. This is 1 unit to the left, so I'm going to go 1 unit to the right. This point is on the y-axis, so it shouldn't move. This point is 1 to the right, so I'm going to go 1 to the left. Okay, this point is 2 to the right, so I'm going to go 2 to the left. Okay, and finally, this point is on the line. It's 3 to the right, so I'm going to go 3 to the left. All right, so I'm going to do my best to connect these dots, and it looks like it's going like this. Okay, I feel like I did not do a great job. Maybe I'll try to cheat. Okay, that looks a little bit better. All right, what about the next one? Now, this is a b value. That is going to be a horizontal, and it's actually going to be a compression or shrink. Everything on the inside is the opposite of what it looks like. So that's bigger than 1, so that actually makes it a shrink. So this is going to be a horizontal shrink or horizontal compression by a factor of 1/2. Okay, you do the reciprocal. So this is going to be a horizontal shrink by a factor of 1/2. So because this is a horizontal shrink, all of the x values will be cut in half. So this has an x value of -2. So that's going to become an x value of -1. All right, this x value of -1 will become -1/2. This one is right on the y-axis, so it's not going to move. This +1 will become 1/2. this positive 2 will become 1. And this 3 will become 1.5. So I'm cutting all the x values in half. I should be able to do my little cheat move just to be more tidy. Ooh, those are too close together. I'll come back to that one. Okay, I was able to do all the cheats except for one. This little guy right here is too short. Okay, there you go. Okay, this minus 3 on the end, all right, that k value means that we're going to go down 3. Okay, and I feel like I can use my cheat mode on that. So this needs to be down 3. I'm just going to copy this thing and see if I can cheat a little bit. Put it down here. Okay, so here it is matching up. So I'm just moving the whole thing down 1, 2, 3. All right, so it should be like this. Down 3. Now this one should be purple, shouldn't it? All right. Oh, the inverse, man. That's what this is. The little -1 is the inverse. All right, I think I'm going to try doing the ordered pair method this time. I'm going to do it in my head, but I'm going to just show you one point as an example. So for this first point right here, this is the point -2, 1. So for example, the point -2, 1 is going to become the point 1, -2. So if I go 1, -2, that's going to be right here. So that's what I'm going to be doing with each one of these points, but I'm not going to write them down anymore. So this is the point -1, 1. So this should become 1, -1. You know what? So this was the point. Okay, I'm sorry. This was the point -1, -1. So if I switch those around, it'll still be -1, -1. So this point's actually not going to move. Okay, this is the point 0, 1. So it should be, okay. This is the point 0, 2. So it should become 2, 0. This is the point 1, 1. So it'll stay 1, 1. This is the point 2, 3. So this should become 3, 2. All right, and this is the point 3, 0. So it should become the point 0, 3. Okay, so this entire graph has been reflected over the line y equals x. So there's this invisible diagonal line going right through here. And the original image has been reflected over this line. So that's going to help guide me. So basically, this graph has turned sideways. So as I'm connecting the dots, they were sort of connected in this up and down pattern. Now they're going to be going side to side. Okay, so it's going to be like this. And you know what? I think I'm going to try to use the drawing tool. Okay, now if you look at the double image as a whole, you can see that the line y equals x splits this double image right down the middle. So in a way, it's a way of checking your answer. All right, so that's how you do the inverse. Ooh, absolute value. Okay, so we're about to do absolute value now. This is going to be interesting. I think I better do this in red so I have a little bit more contrast. So this is absolute value. So look, be careful. What happens if I do the absolute value of a positive number? What's the absolute value of 3? That is going to be 3. So any positive value is going to stay where it is. All right, so this is a positive value. It's going to stay where it is. This is a positive value. This is a positive value. All right, all of these are positive. I'm talking about the y values. They are all of these points are above the y-axis. So they aren't going to move. Okay, the absolute value of 0 is still 0. So all of those points are going to stay put. The only point that has to change is going to be this point down here, because the absolute value of -1 is +1. So basically, anything that's negative is going to be reflected and become positive. So this point down here at -1 is going to be reflected up to +1. It's going to end up right here. Now, the rest of the graph is going to be exactly where it was. Let me show you what I mean. Let me get the right color going. So this part of the graph is unchanged. So I'm just going to trace it in red. Okay, even though this is the new. Now here's where it gets interesting. In fact, I'm going to have to do this part by hand because it's too short. So none of that changed. Now this part of the graph is still positive. It's positive right until it gets to the x-axis. So that part I'm just going to still trace. You know, I feel I should zoom in on this more. Same thing is happening here. This part of the graph right here is positive. So it will not change. It's all above the x-axis until it reaches the x-axis. It's only the little part that dips below. That little part is going to be flipped up, and it's going to go like this. All right, so the majority of the graph didn't move. Only this little part that was negative, absolute value makes it positive, so that little piece, this little piece down here, had to just flip up. But the rest of the graph stayed exactly what it always was. All right, so that was fun to think about. I hope you followed that. Okay. Write the transformed function g of x. All right, the graph of the parent function is translated 2 units to the left and 5 units up. Okay, so look, in general, let's just write the general model down. If the original function was f of x, then g of x, okay, it's got to be 2 units to the left and 5 units up. So if the original function was f of x, then if I move it 2 units to the left, that's going to be f of x plus 2. All right, a plus 2 on the inside moves you to the left 2. If I want to go 5 units up, I'm going to do plus 5 on the outside. So I'm basically going to do this over and over again with different types of functions. All right, I'm going to come back to linear last. Quadratic. Quadratic just means we're talking about x squared. Okay, in fact, maybe I'll put that down the side here. Linear is just x. You know, like y equals x. Quadratic is x squared. Absolute value is the absolute value of x, like that. Rational is a fraction, so that's like 1 over x. All right, exponential is like e to the x. All right, they could have other bases, but this is a good example. Logarithmic, an example of that would be like natural log of x. And sine function would be like sine x. All right, so we are going to do this plus 2 and minus 5. Oh, this is, okay, where it says parent function, that's where they wanted me to write all of this stuff down. Okay, I fixed it. This is what they wanted me to do. So now I'm just going to take each of these functions and do this plus 2 and minus 5 to them. It's just a matter of knowing in each shape where does the plus 2 go. And it should be pretty obvious where the plus 5 goes. I'm going to go from bottom to top. So for sine x, the transformed function g of x would be, all right, so we'll have the sine, and the x plus 2 goes right here, and then the plus 5 goes right here. All right, similarly for the natural log of x, that'll become natural log of x plus 2, and then the plus 5 goes here. All right, now for the exponential function, so this one we have to stop and think for a second because there's no parentheses or anything like that. But just look for the x. Notice wherever the x is, that's your left right. The x shows you where the inside of the function is in a way. So see the x up here in the exponent? That means that's where the x plus 2 is going to go. So this would be e to the x plus 2 power. So just this one's a little bit strange, so I need you to soak this in. Having a plus 2 in the exponent, that's your left 2. That's what it means to be inside the function for an exponential function. Anyway, the plus 5 part is pretty obvious. It's still going to go on the end, like always. Okay, how about the rational function 1 over x? Again, look where the x is. It's in the denominator. That's why in the transformed function, we will have x plus 2 in that denominator. And then we'll have our plus 5 off to the side as always. The absolute value function is pretty obvious what has to happen. It'll become the absolute value of x plus 2, and then with a plus 5 on the outside. How about the x squared? All right, that's going to become x plus 2 squared, and then with a plus 5 on the end. All right, and finally for our linear function, we're just going to go ahead and put x plus 2 in parentheses, okay, and then I'll just put a plus 5 on the end like that. Okay. All right. Okay, so this is the same type of deal, but this time we're going to be doing vertically stretched by a factor of 2 and translated left 8 and down 3. Okay, so vertically stretched by a factor of 2. So that means we're going to have a 2 in the front of the function. Left 8, so that's going to have to be x plus 8. Will take you left 8. And then down 3 will be a minus 3 on the end. So this is what we're going to be doing to all of the functions. Okay, so square root function, the parent function is like this, all right, square root of x. All right, I think I'll just do each one as we go. So there's my square root function. So with the transformations on it, it'll look like this, 2, and then the square root of x plus 8, and then with a minus 3. Next, we have the cubic. So that's the parent function is x to the 3rd power. With the 3 transformations, that's going to look like this, 2 times x plus 8 to the 3rd power, and then the minus 3. All right, absolute value. All right, so here we have our absolute value is the parent function. So here with the 3 transformations, it would look like this. There's the 2, and then we have the absolute value of x plus 8, and then the minus 3. All right, time for a rational. So that's going to be our 1 over x. That's the parent function. Okay, so this is a little bit interesting. Mostly because, like, where do I put the 2? I'm going to come back to that in a second. We talked about on the previous part of this that the x plus 8, we know that's going to go in the denominator like this. We also know the minus 3 is definitely going to go on the end of the whole thing. Now normally what I do is I take the 2 and I'd like put that out in the front, maybe like this. But 2 is really 2 over 1, and when you multiply fractions together, you just multiply straight across. So 2 times 1. So this will quickly become 2 over x plus 8. So that's really the way you want to write that. You don't want to leave the 2 out here. You want to go ahead and multiply it times the 1 and let that become a 2. All right, so that was a little bit different. So that's what it will look like. A vertical stretch by a factor of 2. It's just going to be a 2 up there. Back to exponential. All right, remember that's e to the x power. So with the transformations, I'm going to have the 2, and then my e to the x plus 8 power, and then the minus 3. Logarithmic. Let's do natural log of x. So this will become 2 times the natural log of x plus 8, and then with that minus 3. cosine. Okay, so of course that's cosine of x is the parent function. With the three transformations, that will be 2, and then cosine of x plus 8, and then with the minus 3 on the end. All right, clearly explain each step required to transform f of x into each of the following. So basically, we're just explaining what transformations are happening. That's all they're really saying. Okay, so the plus 6 is going to be left 6. The plus 7 on the end is going to be up 7. Okay, I see 1, 2, 3, 4 transformations here. First of all, the negative sign in the very front means there's going to be a reflection over the x-axis. Now, ignoring the negative sign for a second, just look at the 3. That's bigger than 1, so that's going to be a vertical stretch. Okay, and we should say by a factor of 3. All right, now of course the minus 5 is going to take us to the right 5. And the minus 1 will take us down 1. Okay. Now, this a value of 1/2 is going to be a vertical shrink or vertical compression. By a factor of 1/2. A negative sign inside the function is a reflection over the y-axis. So this is going to have a reflection over the y-axis. And the minus 4 on the end will take us down 4. Okay, 1, 2, 3 transformations. 4 transformations, I'm sorry. The negative sign in the very front, that is a reflection over the x-axis. Now ignore the negative sign. The 2 is a vertical stretch by a factor of 2. And a negative sign inside the function is a reflection over the y-axis. And the 10 on the end will move the graph up 10. Okay. So clearly explain each step required to transform the parent function into the given function. So we're saying the same thing, but in addition, they're asking us what the parent function is for each one. All right, but basically it's the same thing that we just did. So in this case, I see the squared, so the parent function is x squared. The 1/3 in the front is going to be a vertical compression by a factor of 1/3. Okay. And then the plus 6 is going to take the graph left 6. And the plus 7 on the end will move the graph up 7. Okay, clearly the parent function here is the square root of x. Negative sign in the front is a reflection over the x-axis. Plus 5 in this position is going to move the graph left 5. And the plus 2 on the end takes you up 2. All right, that's it. 3 transformations. All right, I see the absolute value. That's the parent function, is the absolute value of x. The negative sign in the front is going to be a reflection. Got lost there. A reflection over the x-axis. The 7, ignore the negative sign. The 7 is bigger than 1. So that is going to be a vertical stretch. By a factor of 7. Okay, so this 4, okay, actually, I see what they're going for here, but they really should have some parentheses inside of here. I'm going to make a command decision and modify this. Okay. To do what they're trying to do, they really are supposed to have parentheses right here. Okay, let's call that a typo. So now, with parentheses around the x minus 3, we can safely say that the 4 is going to be a horizontal something. Now, will it be a stretch or a compression? Everything in here is the opposite of what it looks like. So a 4 right here is going to be a compression. So it's a horizontal compression. Or I could have said shrink. Now, and it's going to be by a factor of 1/4. All right, that's how it becomes a compression, because it's the reciprocal. Now, the minus 3 will be to the right 3. And the plus 9 will be up 9. All right, the reason why I said, hey, we need to put some parentheses in here is because of the following. Let's say if I have 4x plus 12, all right, inside of here. Before I decide what this 12 is doing, I have to factor out the GCF first. So this is really the same thing as 4 times parentheses x plus 3. All right, so in this form, I can see that it's really left 3. It's not left 12, it's left 3. So you have to take out the 4 outside of parentheses before you read it. So I don't think they meant for you to have to do that. So if you take the 4 out, the way they had it, you'd have to have 4 and then x minus, and it would have to be 3/4. I don't think that's what they were going for. So I think they meant to have parentheses. All right. Last one. The negative 2 in the very front is going to be a reflection over the x-axis. The 2, ignore the negative sign. Because the 2 is bigger than 1, that's going to be a vertical stretch. Okay, and we really should say a vertical stretch by a factor of 2. All right, I've been just squeezing in by 1/3 because I didn't have space to say by a factor of 1/3, but you really should say by a factor of. Anyway, the minus 1 is going to be to the right 1. And the plus 4 is going to be up 4. I forgot to write down the parent function, which is x to the 3rd power. That's the parent function. Okay. The parent function here is the exponential function e to the x power. The negative sign in the very front is going to be a reflection over the x-axis. All right, this minus 4, that's a left-right number. So that's going to be to the right 4. And then the minus 6 is down 6. All right, parent function is the rational function 1 over x. The minus 5, this is a left-right situation. This is going to be the opposite of what it looks like. That's going to be right 5. And of course, the minus 3 is down 3. All right, so these are just some notes that are similar to the notes that I gave you at the beginning of the lesson. So they're just worded slightly differently. So feel free to look over these notes, and you can pause the screen and soak this in. But it's that same information that I gave you on the black screen.